All right, let's get started with 1.6, solving right triangles. To solve right triangles means to find the measure of all sides and angles of the triangle. So here what we're going to do is we are going to, again, standardize your triangle like we did before. Remember that little a represents the length of the opposite side of angle A. Little b represents the length of the side opposite of angle B. And the same thing with C. C is reserved always for the hypotenuse, so capital C is always our 90-degree angle. So again, matches our Pythagorean theorem. And we are good to go. Just again, make sure C is always on the hypotenuse. Other things to remember in this right triangle, remember that angle A and angle B are 90 degrees. They're complementary angles. They will add up to be 90. And I'm going to show you some nice things about using capitals A, B, and C with your calculator. So again, hopefully you have your calculator here to practice these. So our first question says solving a right triangle given any angle and a side. Well, come on, thank you very much. So if we want to solve the right triangle ABC, it's best to draw your right triangle. Pictures are worth 1,000 words. So if you want to draw it this way, or if you want A to be here and B up here and C down here, whatever you want to do is fine by me. Then we want to start labeling all your sides and your angles that are given. So 34 degrees, 30 minutes is going here. 12.7 is going in for C. Now the next good thing to do is to write down what it is you're missing. Well, we have angle C, we don't have angle B, and we need sides A and B. So I'm going to write those down. This is what I'm looking for. All right, to find angle B. All right, that's what we're going to find first. That's basically doing this arithmetic right here. Okay, so hold the phone. I need my calculator here. Need my calculator, need my calculator, need my calculator. Here is a really good idea. Because you are going to want to use the given information for everything you find, what is a good idea to do? This would be to store those values. So I would go 34 plus 30 divided by 60, store it in alpha A. There's my angle 34.5. And then that 12.7, store it in alpha C. So this is going to make your calculator entries a little bit easier. So for example, instead of typing this all in, you just have to go 90 minus alpha A. And you want degrees, minutes, and seconds, just hit second, angle, option number 4. There's my answer, 55 degrees, 30 seconds. So I'm going to get caught up on my clicks here. Put that in here, put that down below as your answer. Now you have to find sides A and B. So again, we want to work with these two values. So to find side A, the angle opposite is my 34 degrees, 30 minutes. My hypotenuse is 12.7. That's my sign, opposite over adjacent. So to find side A from this trig ratio, all I have to do is get rid of the division of 12.7. So I multiply 12.7 to both sides. Those cancel. And now that's my calculator entry right there. But again, typing in those values, again, you may accidentally make a typo error. You can just go alpha C, sign. You don't even have to put in the multiplication symbol. And then we put in alpha A. Works great when you're definitely working with degrees, minutes, and seconds, or you have side lengths that are 3, 4, 5 digits long, or maybe 3 digits and 2 decimal places. That's just a pain. 7.193359209. The exact same thing as if you typed it in this way. So there's my side A. So here I rounded it to 7.2 for the following reason. C was 12.7. It was 1 decimal place. So if they don't tell you what to round to, then they're kind of insinuating we want everything rounded to 1 decimal place based off of the information given. Okay? Now, for B, B would be cosine. It's the adjacent side to angle A. Now, like I said, always want to use these same values. So multiply 12.7 again to both sides. There's my calculator entry, 10.46640026. Rounded to 1 decimal place, 10.5. Now again, I want to show you a nice little trick here. Save you time. I don't type this all back in. Here's being sneaky. If you have an older calculator, you hit second, enter. It gives you the previous statement. Or if you got a newer calculator, you can just up arrow until it's highlighted, hit enter. But here's a sneaky trick. If you put the cursor on sine and then hit the cosine, so S on the sine, hit cosine, it removes SIN and replaces it with COS, and you can hit enter, and there's your decimal. So nice little tricks with your trig functions with your calculator to help speed things up. All right. So again, to maintain your accuracy of the problem, always use the given information. Never, ever round something in between. So for example, don't go find the sine of 34.5 degrees first. Round that decimal and multiply it by 12.7. You will be off. And Pearson might give you a very, very small rounding error window. They usually don't. They're looking for these direct entries. So never ever round till the very end. All right, example number 2. We're given 2 sides here. A is 29.43, C is 53. Oh, wait a minute. I'm not even going to go any further. Get my calculator, clear my screen. I'm storing this for A. 29, I can see, I don't know if you see this yet, but if they give you 2 sides of a right triangle, you're going to need the Pythagorean theorem to find the third, and I don't want to be typing these in and squaring them. It's just going to be easier to store it. 53.58, we'll store that in alpha C. Okay, they're stored. All right, let's go to work here. Draw our right triangle. Let's put in our values. Over here is my 29.43. Here's my 53.58. List down what is it we have to find. We got to find angle A, angle B, and side B. What's going to be the easiest to find? All 3. Well, yeah, all 3 are pretty much the easiest. Anything is a good choice. Angle A jumped out at me right away because A is opposite over hypotenuse, there's sine. B, I could use cosine, so adjacent over hypotenuse, and little b, Pythagorean theorem. So let's go with angle A. Sine of A is equal to 29.43 over 53.58. Again, I'm not retyping those in. I've already entered them once. So again, go to my calculator. So sine alpha A divided by alpha C. There's, oh, look what I did. I forgot to hit inverse sine. Ah, you goofball. All right, let's go copy it. Put your cursor on the S. Hit second sine. There we go. Now it's fixed. 33.3170914. So again, here because my problem again has everything to 2 decimal places. Let's go 2 decimal places, so 0.32 for angle A, right there. So let me get that out of the way. Here's my calculator entry. Now, I was storing it here so I can go 90 minus A. I'm going to show you another quick shortcut so you don't have to store again. So here's another quick shortcut. If you go 90, because we don't have to store this value, you can go 90 minus, and there's 2 ways to get this answer. You can go second answer, and it will pull this value down here. There's my 56.68, and I'll round it to 2 decimal places. Or I could go 90 minus, and with the newer calculators, you can just up arrow until you grab the number you want. And I get the same thing. Okay? So my B, 56.68 degrees. Just using complements. Now again, just want to quickly show you, I know I don't want to waste too much time here, but again, we could have went second cosine and then go A over C, alpha A divided by alpha C. There's the same answer. So you have options. So as long as you are writing down your steps and everything's mathematically correct, you're going to get the right answer. Okay, Pythagorean theorem, A squared plus B squared. Wait a minute. Get my calculator back out here. Whoop, let me get to the steps here. We don't want to put those numbers in there and square this minus that squared all inside the square root. Are we crazy? We already got those numbers stored. Second square root. Let's see, that's C, alpha C squared minus alpha A squared. Enter. 44.77378. Okay, click. Same exact answer. Again, rounded to 2 decimal places. Steal the units off of what was given. If they give me units, then make sure we put units down in for the length of B. All right, so that's solving right triangles.